Welcome in the subject Engineering Materials and Metallurgy. So this subject is included in SC Mechanical 2019 pattern. I am Professor A.P. Godke, Assistant Professor in Department of Mechanical Engineering of SND College of Engineering and Research Center, Yaula. Today we will discuss about the unit number 6, that is non-ferrous materials. So what is the need of the material? That is the main criteria. So the material selection and process cannot be separated from the shape and the function of the product. So there will be the two-way interaction between the shape and material selection with respect to the process and the function. So depending on the function and process, the material is going to select, and shape of the material, that is nothing but the process depending on the requirement, the required size and shape. So the choice of the material and process will be restricted by the shape. So all these are the interconnected with each other. Then classification of the engineering materials. So materials are basically classified into two ways. One is the metals and second one is the plastics. Metals further classified into the ferrous metals and non-ferrous metals. So here we are dealing with the non-ferrous metals. So the definition of the non-ferrous is nothing but the metals which does not have the percentage of carbon present in it, and the material does not have a ferrous as a base metal or parent metal. So such metals or materials are called as a non-ferrous metals. So the examples of non-ferrous metals are aluminum, copper, zinc, titanium, and tungsten. Now this is the applications of the non-ferrous metals in industry. So, or in general applications are also there. So copper is the non-ferrous metal which is used for the manufacturing of the coins. Then aluminum is also there. Then titanium and magnesium. So these metals are called as a non-ferrous metals where no carbon is present or no ferrous or iron is present for the base metal. Now non-ferrous metals. So in metallurgy, a non-ferrous metal is any metal including alloys that does not contain the iron in appreciable amount, that is nothing but a maximum amount of base metal. So generally more expensive than the ferrous metals. Non-ferrous metals are used because of their desirable properties such as low weight, for example aluminum, higher conductivity, for example copper, non-magnetic property or resistance to corrosion, for example zinc. And important non-ferrous metals includes aluminum, copper, lead, nickel, tin, titanium, zinc, and alloys such as brass. The precious metals such as gold, silver, and platinum are also called as a, or also comes under the non-ferrous metals. The next is the classification of non-ferrous materials. So there will be two ways for the classification of non-ferrous materials. One is a density based and second one is a melting temperature based. So the light metals and alloys with a density less than 5000 kg per meter cube are called as a non-ferrous materials. So the magnesium, aluminum, and titanium are having a density less than 5000 kilogram per meter cube. So the light metals and alloys are comes under the non-ferrous metals with the less density. Then medium metals and alloys having a density equal to 5,000 to 10,000 kg per meter cube. So sanitine, zinc, Sb, chromium, nickel, manganese, then ferrous and copper are comes under the medium metal and alloy with in the non-ferrous materials based on the density. Then heavy metals and alloys uh, with the density greater than 10,000 kg per meter cube. The examples are Pb, that is a lead, then Ag, Au, tandem, vanadium, molybdenum. So these are the examples of the non-ferrous materials based on the density. So the light metals, medium metals and heavy metals are the non-ferrous materials based on the density. The next classification of non-ferrous materials based on the melting temperature. So first is a low melting temperature. So if the melting temperature is greater than the melting temperature is equal to 327 degrees Celsius. So melting temperature, if it is less than the Tm, so that will be equal to 327 degrees Celsius. Sn, Pb, then Bi are the examples. Then medium melting temperature, the temperature lies between the 327 to 1539 degrees Celsius, like aluminum, then magnesium, manganese, copper, nickel, cobalt, Ag, Au. These are comes under the medium melting non-ferrous materials or medium melting point non-ferrous materials. Third one is the refractory non-ferrous materials having a melting temperature greater than the 1539 degree Celsius. So here in table some of the elements are given and the melting temperature or melting point is mentioned. So for titanium it will be 1660 degree Celsius. For chromium it is 1875 degree Celsius. For vanadium it will be 1900 degree Celsius. For Nb it will be 2415. For molybdenum it will be 2610. For tandem it will be 2996. And for tungsten W is equal to melting temperature is 3410. So from this table you can clearly see that the tungsten is the highest melting point. Therefore, that material also comes under the non-ferrous materials. Next, the comparison of the low density, then corrosion resistance and high temperature strength. So the number of non-ferrous materials are mentioned here. So here magnesium, aluminum and titanium are comes under the low density. Then corrosion resistance, non-metals, noble metals, that is Au, Pt and Ag. Then aluminum, Pb, tandem, copper, titanium, nickel, sanitine, that will be zinc is also there. So that will become under the corrosion resistance. And these two aluminum and nickel, aluminum and titanium are having a common property, that is a low density and corrosion resistance. Next one is a high temperature strength. So cobalt is there, then titanium is there and nickel is there. So these are the comes under the high temperature strength. So here commonly with the corrosion resistance and low density. Next is aluminum and its alloys. So the factor for selecting aluminum alloys are because of it has a high strength to weight ratio, then it has a resistance to corrosion, then it has a high thermal and electrical conductivity, then good machinability, and it is non-magnetic in nature. So these are the properties of aluminum material or aluminum alloy. That's why these are the factors for the selection of the aluminum alloy. So the properties of the aluminum alloys at room temperature are mentioned in the table below. So the alloy 1100, so the temperature tempering is the H14. Ultimate tensile strength is a 90 and 125. Yield strength is 35 and 120, and percentage of elongation in 50 mm steel is 35 to 45. Similarly, another series is there. So just commonly used as a 6061 He30, or it is also called the T6. For that, the properties are mentioned below. So these are the commonly used various aluminum alloys at the room temperature, and its properties are given below.